Let's see this example here. Every quadratic function is of the form ax squared plus bx plus c. And when we complete the form, we have this expression. If you do not know how to complete form, please check the description below for my video on completing squares. So a quadratic function, a quadratic curve has only one turning point. And that turning point could be either a minimum turning point, which means it has a minimum value, or a maximum turning point, which means it has a maximum value. Whether it has a maximum value or a minimum value, there will be corresponding x values. There will be corresponding x value. This expression here represents the value, the maximum value or the minimum value. If a is positive, we expect the quadratic curve to have a minimum turning point and also a minimum value. And this will become the minimum value, and it will occur when x plus b over 2a is 0. In other words, s is equal to minus b over 2a. If a is negative, we will have a maximum value, and that value, this will be the maximum value, and it will occur when x is negative b over 2a. Let's look at some example here. The sum of two real numbers, x and y, is 9. Express y in terms of x. We say the sum of these numbers, x and y, is 9. So clearly, to express y in terms of x, y becomes 9 minus x. B. If p is xy, write an expression for p in terms of x. P is xy, but this is y. Y is the same as 9 minus x. So we can write p as a function of x by opening a bracket. We have 9x minus x squared. C. Say, find the maximum value of p. So if we complete the square, remember p is the same as this is negative x squared positive 9x. If we complete the square, we have p to be negative of x minus 9 over 2 all squared plus 81 over 4. And as we said, in this case, this will be the maximum value of p. This is the maximum value of p, is 81 over 4. And this maximum value of p occurs when x is positive 9 over 2, because this is negative. So x will be positive 9 over 2. Let's look at another example. The diagram shows a rectangular enclosure for keeping animals. There is a fence on 3 sides of the enclosure and a wall on the 4th side. So if we look at this enclosure, there is a fence on 3 sides. This is y. This must be y because it's rectangular, so opposite sides are equal, and this is x. The total length of the fence is 50. Remember, the fence has 3 sides. And those 3 sides are this y, this x, and this y. So y plus x plus y, this y plus this x plus this y must be the total fence, which is 50 meters. So in this case, we can clearly see that 2y plus x is 50 because y plus y is 2y. In other words, y will be 50 minus x over 2. All right. So the question says express y in terms of x, and that is it. B says show that the area, remember A is the area, is this. Okay, so area is the length times the breadth, is x times y. So area is x times y. But y is 50 minus x over 2. So it's clearly x times 50 minus x over 2. And this can be written as 1 over 2x 50 minus x, as proved. This is show that A is this. C. Find the maximum possible area enclosed and the value of x for which it occurs. So if we complete the square, we can find the maximum area and the value of x it occurs. The area is the same. Half times x is 25x minus x squared. This is negative 1 over 2 x squared plus 25x. So if we complete the square, we have negative 1 over 2 x minus 25 squared plus 625 over 2. This is a completed square. So clearly the maximum area is 625 over 2. This is the maximum area. And the value of x for which the area is maximum is x equals positive 25. Remember, this is negative. So x is positive 25. Okay, let's look at another example. Suppose that 300 meters of fencing is available to enclose a rectangular vegetable garden, one side of which will be against the side of a river. So this is a river, okay? So actually we need 3 sides in order to make this enclosure. We need 3 sides because this side is a river. And this comes, it's like the first example. If this length is x and this length is y, of course this length will be y because they say the enclosure must be rectangular. So these opposite sides must be the same. Find the dimensions of the garden that will ensure a maximum area of the garden. Of course, so 300 meters of fencing is available. So the length y plus x must be 300 because this will be used for the fencing. So the same way 2y plus x must be 300. And when we make y the subject, of course you can make x the subject, it doesn't matter. If we make y the subject, we will have 300 minus x over 2. So this is y in terms of x. But we're talking about the dimension. We can see that the area is x times y. Area is length times the breadth times the width of the rectangle. And this is y. So the area is x times y. Y is 300 minus x over 2. Of course, we can simplify this and open the bracket to get negative 1 over 2 x squared plus 300 over 2x. 300 over 2x. If we complete the square, one more time, if you do not know how to complete a square, please check my videos on completing squares. If we complete the square, we have negative 1 over 2 x minus 150 all squared plus 1. Let me write it properly. Create some space here. If we complete this square, the area will be negative 1 over 2 into bracket x minus 150 all squared plus 11250. So clearly this is the maximum area 11250, and the area is maximum, or the maximum area occurs when x is 150. So if x is 150, we can find y because this is y. This expression is y is 300 minus x over 2. So if x is 150, y will be 300 minus 150 over 2. And this will be 300 minus 150 is 150 divided by 2, that is 75. So y will be 75. Of course, you can check and see if the area will be 11250 by multiplying x by y. So that is okay. Let's look at another example. So these are the dimension. Dimension is x by y, and x is 150. So the dimension must be 150 meters by 75 meters. Okay, let's look at the last example. Charles wants to build a vegetable garden such that 3 sides of the garden are fenced and the 4th side of the garden will be an existing back fence. So this is like the first one. If this is the fence, these are the 3 sides which will be built. These are the 3 sides which will be built. Let me use black for it. Against an existing fence. He has 30 feet of fencing available. So if this length is x, and this is y, of course this will be y. It doesn't matter. You can say this is y, x, it doesn't matter. So the fencing available is 30. So y plus x must be 30. And 2y plus x equals 30. So in this case, y is 30 minus x over 2. Of course, you can make x the subject. It doesn't matter. They say find the dimensions of the garden that will produce a maximum enclosed area. The area will be the length, which is x multiplied by y. So it will be xy. But of course, we know y as 30 minus x over 2. So it's x multiplied by 30 minus x over 2. If we rearrange this properly, we got negative 1 over 2 x squared plus 15x. And we can complete the square. Let me continue somewhere here. If we complete this square, we have negative 1 over 2 x minus 15 all squared plus 225 over 2. So in this case, this is the maximum area. That is 225 is the maximum area. And the maximum area occurs when x equals 15, positive 15, because this is negative. So if x is positive 15, what will be y? Remember, this is y. Y is 30 minus x over 2. So y will be 30 minus x over 2. And that is actually 15 over 2, or 7.5. So y will be 7.5. So the dimensions, say find the dimensions. The dimension is x by y, x by y. So it is 15 feet, because x is 15 by y, which is 7.5 feet. If you like this video, please subscribe to this channel. See you again in the next video.